Hello, I want to talk to you guys about absolute value inequalities. Before I do that, call a couple things just so we can get back on track. So absolute values make things positive. What that means is, right, if I say the absolute value of 5, that means that's a 5. Or if I say the absolute value of -3, it makes it positive. This is just going to be a +3. When we talk about the definition, it kind of explains why things are always positive. So the absolute value of a number is the distance of the number from 0 on the number line. So you look at, let's do a 5 here, right? Here's 0 and here is 5. This distance here is 5. So there's 5. Is a positive distance. Whereas look at the other one, the distance of -3 to 0, the distance here is 3 units. Distance is always a positive number, so that's what we're looking at. Okay. So if you recall, we did something like this earlier. If I want to solve an absolute value inequality, right? This is saying the absolute value of x is 5, or the distance of x from 0 number line has to be 5 units, which gives you a picture like this. Here's 0, here's 5, this distance right here is a 5. If we go to -5, the distance from 0 still is 5. So I'd say x equals 5 or x is -5. And as mentioned before, what's on the inside doesn't really matter. So you could summarize this as, if the absolute value of something, we'll say this, if the absolute value of whatever is on the inside equals some letter c, that means its distance from 0 is plus c and minus c. Then our answer looks like this: inside, whatever that is, equals positive c, or inside equals minus c. That's kind of a summary how that works. Now, that's an equation. We're solving inequalities, so it's going to be a little bit different, but still the same basic idea. Let's look at solving the absolute value of x, say equals, is greater than 5. The absolute value of x is greater than 5, you're saying the distance from x, this distance of x from 0 is bigger than 5. So look at a number line, what are we saying? Here's 0. If I travel to the right to 5, this distance right here is 5. We're looking for the absolute value of x is greater than 5 means the distance of x from 0 is larger than 5, which means I need to be going everywhere over here. If you go the other direction, this is the distance of 5 right to here, to -5. If I want this distance to be larger, I'm going way over here. So this means x is either going to be greater than 5, which is right over here on the right side, or x is going to be less than -5. And that would be our solution. And really, as mentioned, it doesn't matter what the inside of your absolute value is. It could be x, it could be more complicated, it could be less complicated. Our rule says this: if whatever the inside is, the absolute value of the inside is greater than 5, not 5, is greater than some number c, then the inside is greater than C, or the inside is less than C. And that's our rule. And if we come back here, down here, this is also a rule here. Now, in both cases, these two rules, we should note that here, C has to be greater than or equal to 0, and the same way here. All right, let's try an example. Four plus 3 minus 2y is greater than 6. So 4 plus the opposite value of 3 minus 2y is greater than 6. Now the first thing you gotta keep in mind is the rule here, right? The absolute value, this absolute value right here, is by itself. So I have to get rid of the 4. So it's 4 plus, so I'm going to add the opposite of 4, so minus 4 here, and minus 4 over here. So I get the absolute value of 3 minus 2y is greater than 2. So it's going to be inside is greater than 2, right? According to our rule, inside is greater than C, then the inside is greater, sorry, if the opposite value of the inside is greater than C, then the inside is either greater than C or the inside is less than C. So we have a greater than 2, or we have a less than minus 2. That should be minus right up here. And then whatever is right here, I'm going to put here. So 3 minus 2y is greater than 2, or 3 minus 2y is less than minus 2. And then we're going to solve. Minus 3, minus 3. Minus 2y is greater than minus 1. And then we're going to divide by minus 2. And remember, when you divide by a negative, the inequality is switching directions. We have y is now less than positive 1/2. Or, so in this one, it's going to solve almost the same. Minus 2y is less than minus 5. Divide by minus 2, divide by minus 2. Y is greater than, because I divide by negative, 5 over 2. And because there's inequalities, we're going to graph them on a number line. Make sure you get your orders correct, right? So make sure the smallest number comes first. So here's 1/2, then 5/2 is bigger, so it'll be over here. Y is less than 1/2, so all numbers smaller than 1/2, so it's going to be everybody up to here. And then y is greater than 5/2, all numbers bigger. And you'll note, strictly less than, strictly greater than means I can't equal either the 1/2 or the 5/2. So I'm going to have to put either open circle, or I like to do parentheses, so parentheses here, parentheses here. So that's what the number line is going to look like. If you're asked for interval notation, it's going to work the same way. You're left to right. The key here in this problem is how many shaded areas you have. If you have one shaded area, you have one interval notation. If you have two shaded areas, you'd have two interval notations. If you have three, you'd have three interval notations, and so forth. So we have two shaded areas. So we're going to start with the first one. We'll go left to right. So I have here minus infinity. It goes up to 1/2. So my first interval, minus infinity to 1/2. My second interval, nothing in between, starts at 5/2. It goes all the way to plus infinity. Now recall, infinity will always get a parenthesis because you can never reach it. So parenthesis here, parenthesis here. And then for the 1/2 and 5/2, I take whatever I have on the number line. So I had parentheses here, so parentheses down here. If you want to be fancy now, we should say this is the interval of -infinity to 1/2. This means it's union, so this is a union. 5/2 to infinity. And union is just a fancy way of saying or. So the numbers we're interested in are either the first interval or they're in the second interval. All right, so that is absolute values greater than. We need to talk about absolute values that are less than. So let's look at an example. The absolute value of x is less than 5. Or we're saying this is the distance of x from 0 is smaller than 5. Let's take a look at that. Here's 0. If I go all the way to 5, right, that distance is exactly 5. I don't want to go all the 5, I just want to go up 2, so I'm going to go like right up here. If I go to the left negative, if I go all the way to -5, right, all the way to -5 has the exact distance of 5. If I want to be smaller than that, I have to be somewhere below this. So the absolute value of x is less than 5 means I want all the distances smaller than 5. So I can go to the right just shy of 5 or to the left just shy of -5, reaching -5. So I do 4.9 or -4.9. Or this means that our x is in here. So the answer here would be -5 is less than x and x is less than 5. So it has to fall in between here. Again, it doesn't matter what your inside is. So if my inside was bigger or more complicated, it's still between -5, the less than the inside is less than 5. So our rule says if the absolute value of the inside is less than some number, c, then the inside is between the bigger number and the small number. So it's sandwiched between -5 and +5. And this is our rule. Again, c has to be greater than or equal to 0 for it to work. All right, let's try an example. Solve 4 times the absolute value of x plus 3 is less than or equal to 28. Okay. So, again, in order to use these rules, the absolute value must be alone. So this 4 right here is causing us a problem. And how you get rid of it depends on how it's connected, right? This is 4 times the absolute value. I want to break multiplication, so we're going to divide. 4 goes into itself 1 time. So I get x plus 3 is less than or equal to 7. Okay. And now, because it's less than or equal to, it's basically less than, right? Less than means I start at 0, I go as close as I can to the right to get to 7, plus 7, or I go as close as I can to the left to get to -7. So the inside is in between there. So we have -7, it's less than or equal to the inside, which is x plus 3, which is less than or equal to 7. And now I have this compound inequality. And when we're solving these, we just want to get the x by itself in the center. So we're going to subtract 3 minus 10 is less than or equal to. Minus 10 is less than or equal to x, which is less than or equal to 4. What this is saying is x is between minus 10 and positive 4. So you have to graph a number line for this. This is, I want everything shaded between minus 10 and positive 4. And because this is strictly greater than, less than or equal to in both places, put a bracket here and a bracket there. And then for interval notation, left to right. So my left side is minus 10, my right side is 4. Because it's strictly less than or equal to, right, we're going to have brackets. Those are my solutions. Okay. Talk about a quick couple of special cases. What would happen if this absolute value equals negative? Or not equals, greater than an absolute negative number. So when this number here, the number is related to absolute value, it kind of depends on whether you have equal to or greater than or less than. So what do we know? Minus 5 is negative. The absolute value, the left side of the equation, is absolute value, so it's going to be positive. So can a positive number be greater than a negative number? Yeah, I hope so. That's true, right? That's a true statement. And how often is that true? All the time. So your answer is all real numbers, which you could write with the fancy R, or you could just write the interval notation as minus infinity to positive infinity. So that's what happens when they have absolute value greater than negative. What happens when we solve a situation where the absolute value is less than a negative? So the distance of the inside from 0 is minus 3. That doesn't really make a lot of sense when we say it out loud. Distance can't be negative, so it doesn't make sense. But again, just work it out. The right side, because the absolute value will always be a positive number. The left side is negative. So can a positive be less than a negative? Sure can. So this is false. So your answer, well, no solutions. Or you can write the null set, or the empty set as it's called. So just be aware, if the absolute value is related to a negative number, it'll basically either be no solution or all real numbers. And it's going to depend on whether it's greater than or less than or just straight equals. All right, that's everything you know about absolute values. Well, actually, there's one thing we can talk about real quick. What happens if I get something like the absolute value of x plus 5 equals to the absolute value of x minus 3? How do you solve this? Well, you basically just do it like you did before. If you treat this like the c value, it's going to be the inside, x plus 5, equals positive c, in this case, so positive x minus 3, or the inside equals minus the other side, so x minus 3, and you lose the absolute values when you do that. So in our case, if you solve this, you have minus x and minus x on the right side. So 5 equals minus 3. So this side doesn't give me any food because 5 can't equal minus 3 and that's done. Over here, I have minus x plus 3. Add x to both sides. 2x plus 5 equals 3. Subtract 5. 2x equals minus 2. X equals minus 1. Sometimes in a situation like this, we have absolute value equals absolute value, you get one solution, or sometimes you get two. But in this case, we just get one. All right, if you have any more questions, please let me know.